Truss analyzes method of joint. This method for finding the force consists of satisfying the condition of equilibrium for the forces acting on the connecting pin of each joint. The method therefore deals with the equilibrium of concurrent forces and only the independent equilibrium equations are involved. We begin the analysis with any joint where at least one known load exists and where not more than two unknown forces are present. The analysis with any joint where at least one unknown load exists one now. Exists and where not more than two unknown forces are present. The solution may be started with the pin at the left end. Its free body diagram is shown in the figure. For example, consider this picture. With the joints indicated by letters as shown in this picture, we usually designated the force in each member by the two letters defining the ends of the member. The proper direction of force should be evident by inspection for this simple case. The free body diagram of portion of members, for example AF and AB, are also shown to clearly indicate the mechanism of the action and the reaction. The action on P, for example, and the reaction on the member. This is on the member is on tension, the member is on compression, and the opposite and equal force on the P. The members AB actually makes contact on the left side of the pin as shown in the picture. Although the first AB is drawn from the right side and is shown acting away from the pin, it is the effect of the force on the member is important for determine the compression and tension members. Thus, if we consistently draw the force arrow the same side of the pin as the member, then the tension will always be indicated by arrow away from the pin, and compression will always be indicated by the arrow toward the pin, as shown in the picture. As we said, the reaction on the member is important to determine the compression and tension members. The magnitude of AF, for example, is obtained from the equation in y direction. Sigma F sigma Fy. We can calculate, for example, AF sinus theta minus R1 AF R1 sinus theta. An example, and we can also calculate the sigma Fx to calculate AB minus AF cosinus theta equals to 0. Joint F may be analyzed next, since it now contains only two unknowns EF and BF. In a truss, for example, the free body diagrams for various member trusses are shown in the next picture. Consider this picture, and the free body diagram for each joint shown separately. This picture shows the free body diagram of each point and its corresponding force polygon, which represent graphically the two equilibrium conditions for each joint. Sigma F sigma Fy for joint A, this point, the AF, the AF and AB members, and we said that the force on the members is important to determine the compression and tension condition. This member is in tension, compression, and is in the tension. For the point F, this point, we have three forces. This is in compression, and tension. And also, our assumption for the member AB should be applied also in this point. AB was in tension, and also BF previously selected as a tension part, and in this condition we have also tension member, and tension member. All other members also be, all other assumptions should be applied on the other joint. For example, for joint C, the BC assumption in this picture should be applied also in this point. BC is tension, and tension. This is in compression, tension, compression, tension. Yes. The numbers indicated the order which the joint R analyzes. We note that when the joint D is finally reached, the computed reaction R2 must be in the equilibrium with the force in the member CD and ED, which were determined previously from the two neighboring joints. This requirement provides a check on the correctness of our work. Note that isolation of joint C shows that the force in CE is 0 when the equation in the y direction is applied. The force in this member would not be 0, of course, if an external vertical load were applied at C. It is often convenient to indicate the tension T and compression C of the various members directly on the original Truss diagram by drawing arrows away from the pins for tension and toward the pin for compression, the opposite to the members. This designation is illustrated in these pictures. Sometimes we cannot initially assign the correct direction of one or both of the unknown forces acting on a given pin. If so, we may make an arbitrary assignment. A negative computed force values indicated that the initially assumed direction is incorrect. Internal and external redundancy is the next section.